GMAT all day.
Welcome to our geometry series on quadrilaterals. This should be the shortest of our geometry series, but that does not necessarily mean there's less to know than any of the other ones. So if you are following along with our cheat sheet, we are here. These are all the things you should know and have memorized after completing the quadrilateral videos. So let's get right into it. Let's start by just talking about the different types of quadrilaterals and their properties, as well as how they are connected. This diagram here that looks like a flowchart, I think of it as sort of a hierarchy of quadrilaterals. In other words, as you go down the flowchart, every shape contains all of the properties of the things that come before it, or the things that are connected to it. So to be a quadrilateral, which all of these shapes are, what do you need? You just need to have four sides. So any polygon with four sides is a quadrilateral. They do not discriminate. You have four sides, you're a quadrilateral, no questions asked. And so then how do you go from being a quadrilateral to being a parallelogram? Well, there are two ways. And so a parallelogram is going to be a quadrilateral where your opposite sides are parallel and equal length. And it's also going to be true that your diagonals are going to be bisectors of each other, or they split each other in half. Now, while both of these things are true of any parallelogram, in order to go from being a quadrilateral to being a parallelogram, you just need to know one of these things, because if one of these things is true, the other is necessarily going to be true. So if you have any sort of quadrilateral and they tell you that the diagonals are bisectors of each other, you know that that quadrilateral is a parallelogram, which also means its sides are going to be, or its opposite sides are going to be parallel plus equal in length. So next, how do you go from being a parallelogram to being a rectangle? Well, to do that, you just need to know that you are a parallelogram where one of the angles is 90 degrees. And so a rectangle is just a parallelogram where one of the angles is 90 degrees. And you might say to yourself, well, I know what a rectangle is. I've seen a rectangle before. I graduated kindergarten. Aren't all of the angles in a rectangle 90 degrees? Well, that is true. But to go from being a parallelogram to being a rectangle, you just need to know that one of the angles is 90 degrees. And that will necessarily mean that all of your angles are 90 degrees, because otherwise you would not be able to close that shape. So even though it is true that for a rectangle, all of your angles are 90 degrees, you only need one of those angles to be 90 degrees in order to go from a parallelogram to a rectangle. What about a rhombus? Well, with a rhombus is going to be a parallelogram where all your sides are equal length. So with a parallelogram, only your opposite sides had to be equal length. With a rhombus, all sides are equal length. And your diagonals are perpendicular bisectors. And just like with a parallelogram, going from a quadrilateral to a parallelogram, in order to go from a parallelogram to a rhombus, you only need one of these things to be true, because if one of them is true, then the other one is necessarily going to also be true. And so this leaves us just with a square. And so a square has the properties of everything else that comes before it. So a square is just a rhombus plus a rectangle. So if you know you have a rhombus and then they tell you one of the angles of that rhombus is 90 degrees, well, congratulations, you are now a square. Likewise, if you have a rectangle and they tell you that all the sides of your rectangle are equal length, congratulations, that rectangle is now a square. And so this is really just a rectangle plus a rhombus. And so a square is a rectangle, a square is a rhombus, but a rhombus is not necessarily a rectangle, and a rectangle is not necessarily a rhombus, which is why they are not connected on the flowchart. But both rhombi and rectangles and squares are all parallelograms. and all parallelograms are quadrilaterals. That is the hierarchy of quadrilaterals. Those are their different properties. Sometimes they like to test these properties sort of straight up, especially with data sufficiency questions. And in those cases, it's sort of like you either know it or you don't. So these are worth knowing, memorizing them. And now in the later videos, we will do some questions testing these properties.